Today we'll be talking about the distance and midpoint formula. By the end of this lesson, you should be able to find the distance and midpoint between 2 points, as well as use that information to assess and answer other questions regarding graphs of points and lines. Let's begin with the distance formula. You learn the distance formula in geometry, and what we do is we take two different points, whatever those 2 points may be. We're going to call them x1, y1 for the first point, and x2, y2. Remember that little subscript number is just another way to tell you which point is the first point and which point is the second point. And what we do is we subtract the two x's, and then once we subtract them, we square that number. And then we subtract the two y's, and once we get that number, we square that number. And then we add those two numbers together. Take the square root of it if possible, if not reduce it if we can, and that will give us the distance between the 2 points. Now it doesn't matter if we put x2 first or x1 first, same thing with the y1 and the y2. We're going to square that number anyways, so the sign of the actual number doesn't really matter. Then we have the midpoint formula, and the midpoint formula tells you in the name of the formula that you're going to come up with a point. So this should help you remember the difference between the distance formula and the midpoint formula. The midpoint formula, we need to come up with a point. So we need an x value and we need a y value in order to come up with that point. And what we do essentially is just take the average of the two x's and put that in place of the x. And we take the average of the two y's and put that in place of the y. So let's try out some problems now. So we need to find the distance between these 2 points, 2, 4 and 3, 8. And we can call this x1 and y1 and call this x2 and y2. And then we plug that into the distance formula. X2 minus y1 squared plus y2 minus y1 squared. And then we simplify it down. 3 minus 2 is 1. 1 squared is 1. Plus 8 minus 4 is 4. And 4 squared is 16. And then combine that together to get 17. And 17 is a prime number, so we can't reduce that any further. Now if we had switched the numbers around and had done 2 minus 3 instead of 3 minus 2, we would get negative 1. And when you square negative 1, you get positive 1, which doesn't change this number here. Same thing with 8 minus 4. If I switch those two numbers around and do 4 minus 8, then I get negative 4. And negative 4 squared is still 16. So you should notice the order of the x's and the y's really doesn't matter when we use the distance formula. Now if we're trying to find the midpoint, remember we're trying to find a point. And we're going to take the average of the two numbers. So we take 2 plus 3 and divide it by 2. And we take 4 plus 8 and divide it by 2. 3 plus 2 is 5, so we get 5 over 2, or 2.5. And 4 plus 8 is 12, and 12 divided by 2 is 6. And we want to leave that x an improper fraction. Rarely do we ever see 2.5 in our coordinates. So now let's pause the video and you try this one. Okay, so let's find the distance. And again, if it makes you feel better, you can label them above it so that you remember which one is x1 and which one is x2. Then we plug it in, negative 3 minus a negative 1 squared plus negative 6 minus a negative 3 squared. Let's fix that square root sign. And then we evaluate, being very careful with our integer operations here. Negative 3 minus a negative 1, that's the same as adding the opposite. So I end up with negative 2 squared, which is 4. And then negative 6 minus a negative 3, that's the same as adding the opposite. So I get negative 3 squared, which is 9. And when I add that together, I get the square root of 13. And again, this is a prime number, so I can't reduce it any further. Pause the video and now try the midpoint formula. So if we're trying to find the midpoint, we take the average of the two numbers for both coordinates. Negative 1 plus negative 3 is negative 4. Negative 4 divided by 2 is negative 2. Negative 3 plus negative 6 is negative 9, and negative 9 divided by 2 doesn't go in evenly, so we can leave it as an improper fraction. Now here's an application problem, which should look very similar to what you had in geometry. This is asking us to classify the triangle ABC as scaling, isosceles, or equilateral. And even if we were to graph the points, you still wouldn't know for sure if it is scaling, isosceles, or equilateral. Remember that those three vocabulary words had to deal with the length of each side. So in order to determine if it's scaling, which meant all sides different, different lengths, or isosceles, which meant two sides equal or congruent, or equilateral, that was all sides congruent, we need to know how long the sides are. So we're going to take and find the distance between AB, and then find the distance between BC, and then find the distance between AC. Because that's the only way we're going to know if it's a scaling, isosceles, or equilateral triangle. So now we use the distance formula, which can be slightly tedious, but it's the only way we can figure it out. So we take 4 minus 7 squared plus 6 minus 3 squared. 4 minus 7 is negative 3, and square that we get 9. 6 minus 3 is 3, square that we get 9, and we get the square root of 18. Which we can reduce, but if all we're doing is comparing the distances or the length of the sides, we can keep it as a square root of 18, so it's easier for us to compare. Then we do BC, 7 minus 2 squared plus 3 minus 1 squared. 7 minus 2 is 5, and 5 squared is 25. 3 minus 1 is 2, 2 squared is 4, so the distance between there is 29. So already we know it is not going to be equilateral. And then we find the distance between AC, that's 4 minus 2 squared, plus 6 minus 1 squared. 4 minus 2 is 2, square that and you get 4. 6 minus 1 is 5, square that and you get 25. So the distance between AC is 29. So we have the distances being 18, 29, and 29, the square root of the 3. So two of them are the same size, so this triangle is isosceles. Now you pause the video and try this one yourself. Okay, we're going to find the distance between AB. We get negative 1 minus 5 squared plus 3 minus 2 squared. Negative 1 minus 5 is negative 6. Negative 6 squared is 36. 3 minus 2 is 1, and 1 squared is 1, so that side is 37. And we try BC. 5 minus 3 squared plus 2 minus 6 squared. 5 minus 3 is 2, and 2 squared is 4. 2 minus 6 is negative 4, and negative 4 squared is 16, so this is going to be the square root of 20. So again, not equilateral. And then we try AC. AC, we get negative 1 minus 3 squared plus 3 minus 6 squared. Let's extend that, fix that square root sign. Negative 1 minus 3 is 4, and 4 squared is 16. 3 minus 6 is negative 3, and negative 3 squared is 9. So the distance of that side is 25. So because the distance is the square root of 37, the square root of 20, and the square root of 25, all the sides are different sizes, or different lengths, so we have a scaling triangle.